Hello, and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of writing exponential functions. This is standard A.9C in the great state of Texas. We are using item number 47, the 2025 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. All right, so we have a bank customer with an opening account balance of $2,500. We've got interest on the account, and it will increase it by not 5%, 0.5%, or 5/10ths of a percent. And so we need to find a function that can determine its value after t years. All right. And so if we're thinking about interest, they don't give us any clue as to whether it's compound or whether it's simple interest. And if we look here, we're not going to necessarily see anything that's going to help us. In previous grade levels, we would have something that would show us the formula for our compound interest or the formula for our simple interest. And so one thing we need to keep is when we're dealing with money, we're dealing with interest. A lot of the times we are dealing with the compound interest. And that means we are dealing with exponential functions. Now, before Algebra 1, we didn't really deal with exponential functions on their own. We just dealt with that compound interest, and we had to use uh, you know different formulas to try to figure out what that was. But now we know that that was an exponential function, and we are dealing with a standard form of y equals a times b to the x. Now let's make sure we understand what each of these terms means. So this a is going to be our initial value, or it could be our uh, initial balance, right? It can be our deposit. That's what it's going to be in this situation. It's going to be our starting position, something. It's what we start with. And so in this case, we are dealing with money, so it is going to be our initial balance. So our A is going to equal 2,500. So we can take a look at each of these. That's not in doubt. Every single one of these has 2,500 as the initial value. So that doesn't help us at all. Our B is going to be our rate. So this rate is given to us as this 0.5%. Now look at our rates. Our rates are given to us as decimals. So we need to convert our decimals or percents into a decimal. And this is where we get tricky because this is 5/10ths or 0.5% or per 100. So if we were to turn this into the hundredths, this would be 0.0, and then there's my hundredths. I don't even have a full hundredth. I have half of a hundredth. So I've got to get over here. So it ends up being thousandths, right? So this is 5/1000ths. If you multiply both of those by 10, or you can simply take your decimal and you can move it over twice to the left. So either way you look at it, it's going to be 5/1000ths. Well, that's going to eliminate some answer choices here. You're not going to see 5/1000ths here because that's simply uh, the initial increase. So this is a growth rate. And whenever you do that, you are going to need to go ahead and add 1 to get it to 1.005. It's a decay rate. You would subtract that from 1. So this is a growth rate because it is increasing. You're going to add interest every single year. So we need to add that 1. So now I've got just B and C that have the correct rate. And then this x is going to be our time, but you notice it is an exponent. And D does not have it as an exponent. It's just a regular number you're multiplying. The only one that has it as an exponent is that B. We need this t to be an exponent rather than just a regular number you're multiplying. And so our answer is going to be B.